Hi everybody, this is lecture 3, part 1, estimating summary statistics. So we have seen what is quantitative data, the two types of quantitative data, that is discrete data and continuous data, how to represent them using frequency tables. We have also seen the summary statistics and how to determine them, how to calculate them. We also seen how to represent these summary statistics using box and whisker plot and how to draw and interpret histogram and to study the shapes of data. So now we're going to see is how to estimate the summary statistics, the mean, the variance, the standard deviation, and the quartiles. So first we're going to see why we need to estimate the summary statistics and when we need to use it. Yeah. So let's see why we need this and when will we be in a situation where we have to estimate the summary statistics. Okay, so let's recall what we learned about grouped frequency table. Yes, we have seen that when data is continuous, it can be summarized using the grouped frequency table. So this table clearly tells us there are two data in the class 3 to 3.9. There are two data in the class 4 to 4.4. There are four data in the class 4.5 to 4.9 and so on. So what if we are only given this grouped frequency table? That is, I give you just this grouped frequency table and we don't know the original individual values. We don't know the original values, the data values. We just know that there are two data within this class. There are two data within this class. There are four data within this class. There are 8 data within this class. There are 6 data between 5.5 and 5.9. There are 3 data between 6 and 6.4 and 5 data between 6.5 and 7.4. We do not know the original individual values. That is, we don't know the data values. We don't know this. Yes. So how are we going to find the mean, standard deviation, and the quartiles? In such situations, it is still possible, but you can't determine this time. We can estimate the summary statistics. So it is still possible to derive estimates of summary statistics when all we have is grouped frequency table. So that's what we're going to see. So when the data is not given to us, all the individual data values are not given, when we have just the grouped frequency table, then how are we going to estimate the summary statistics? That's what we're going to see today. That's our learning objective. Okay, so when we only have group data, we can estimate the mean, the variance, and the standard deviation, and the quartiles. For this, we need 3 important values. Yeah, that is class boundaries and class width. You already know how to find class boundaries and class width from the group frequency table and from the histogram. Yes. Now we need the third one, that is midpoint value. So we're going to see what is midpoint value, and then we are going to work on how to estimate the mean, the variance and standard deviation, and the quartiles. Okay, so we know class boundaries, how to find the class boundaries. We know how to find the class width. Let's see what are midpoint values. What are midpoint values? Midpoint value, as the name says, it is the midpoint value. It's a middle value between the lower class boundary and upper class boundary. And how are you going to calculate it? Just find the average. So lower class boundary plus upper class boundary divided by 2. So the value in between this. So we have 2.95 plus 3.95 divided by 2, which is nothing but 3.45. Yes. Similarly, for the class 4 to 4.4, what is the midpoint value? 3.95 plus 4.45 divided by 2. and you get the midpoint value. What is it? 4.2. Yeah. Similarly, for 4.45 and 4.49, what is the midpoint value? Add the two class boundaries, lower class boundary plus upper class boundary divided by 2. So you have 4.45 plus 4.95 divided by 2. So it is 4.7, isn't it? Yeah, 4.7. Now what I want you to do is find the midpoint values for these classes. Excellent, guys. Thank you very much for writing it down. Very good. Yes, it is 5.2, 5.7, 6.2, 6.95. What did you do? You added the lower class boundary and the upper class boundary and divided it by 2. Very good. Yeah. So you know what is midpoint value. Now we are going to estimate the mean using the midpoint values. Let's see how we do that. Yeah. So we have the class, we have the frequency, the midpoint value. Yeah. So now what we need to know is, so if the midpoint value is 3.45 for this class, it means there are two data values within this class, which is either 3.45 or less than 3.45 or greater than 3.45. Similarly, if the midpoint value is 4.2 for this class, that means there are two values within this class, which is either 4.2 or less than 4.2 or more than 4.2, but they will average to 4.2. Yeah. So when you sum up and add them together and find the average, the value should be 4.2 or less, or some value close to that. Yes. So it could be around 3.45 in this class. It could be around 4.2 in this class. That's what it means. So midpoint value just helps you to know that there are 4 values within this class, which is either 4.7, less than 4.7, or close to 4.7. But when you take an average of all the 4 values, it should be closer to 4.7 or 4.7 itself. Okay, so that means, again, within this class, between 5 and 5.4, there are 8 data values which average to 5.2. That means if you add all the 8 data values and take an average, it will come to 5.2 or less than 5.2 or greater than 5.2, but closer to 5.2. Yeah. So that's what I'm trying to tell here, that some values in a class will be less than the midpoint value. Some will be greater than the midpoint value, but they will average to a value close to the midpoint value. Oops. Point value. Okay. That's what we should understand here. So instead of saying, because we don't have the data here, so we can say that there are 2 values which are close to 3.45. There are 2 values which are close to 4.2. Okay. So we can estimate the mean by assuming that each value in a class has the midpoint value of the class. This is just an estimation. Yeah, we are assuming it. It's because we want to estimate the mean. So we assume that each value, there are 2 data value in this class. Each value in a class has the midpoint value of the class. So let's imagine that the 2 data values in this class is 3.45 and 3.45. In this class, it is 4.2 and 4.2. In this class, it is 4.7, 4.7, 4.7, 4.7. So we are just assuming that the data values are around this value. Okay, so this is an estimation. So therefore, there are 2 values in the class, 3 to 3.9, represented by 3.45, represented by its midpoint value. 2 values in class 4 to 4.4, represented by 4.2, and so on. Okay, so now our task is to estimate, not determine or calculate, estimate the mean. So let me say F is the frequency and M is the midpoint. Just like how we usually calculate the mean. How do we calculate the mean? If the data is given, if individual data value is given, you just add up all the data values and divide it by the number of data, isn't it? Similarly, here we have imagined that each class has a data value equal to the midpoint value. That means we have 3.2 data, which are 3.5 and 3.5 within this class. Similarly, within this class, you have 4.2, 4.2, two data value. Yeah, here we have 4 values. So 4.7, 4.7, 4.7, 4.7. So you have to add them all up and divide it by the total number of data values. 2 plus 2 plus 4 plus 8 plus 6 plus 3 plus 5, which is nothing but 30. Okay, so let's get a formula for that. So x bar is equal to sigma mf by n, because you're going to multiply 2 times 3.5, because we have 2 3.5. 2 times 4.2, 4 times 4.7, 8 times 5.2. And then add it all up, just like how we did the mean. Okay, so we have 30 data values. So we substitute there and we get the mean. Okay, so we find the mean. So now let's compare this with the original mean, the actual mean, which we calculated a couple of weeks ago using the original data, cholesterol data. Yeah, and we found that it was 5.45. Look at that, how close they are. This is 5.44. This is an estimation. Can you see this? It's an estimation. It's not equal to, it's an estimation, but this was from the actual data itself. So it is almost very close. So our estimation is almost close. Yeah. Anyway, so this is what you have. This is how you can estimate the mean when your data is missing. You don't have the data, when you are given only the grouped frequency table. So you can use the midpoint values to estimate the mean. Okay, now we have seen how to estimate the mean. Let's see how to estimate the variance and the standard deviation. Okay, just like how we calculate the standard deviation here, instead of squaring x square, we square the midpoint. So m square. So if this is m, this is m square. So we are just squaring the midpoint value because we consider that each data value is equal to the midpoint value. Each data value is equal to the midpoint value. Each data value is equal to the midpoint value. So you just square the midpoint value. And then you find the sigma x square and then use the formula for standard deviation, find the standard deviation. So you're going to substitute the sigma x square there. N is 30, n is 30, and the mean is the mean square. You see, the mean square. Mean, we just found out mean is 163.25, isn't it? Remember, we just found it. 163.25 over 30. So you use that and then find the standard deviation. Okay, now let's compare this with the actual standard deviation, which we calculated a couple of weeks ago using the original cholesterol data, which was S is equal to 0.92. Look at that. Our estimation is close, isn't it? Anyway, so this is how you you estimate the standard deviation from the group frequency table if we do not have the individual data values. Okay, okay. So now we have seen standard deviation, and how will you find the variance? Just square it. So if S is this, variance is going to be S square, which is nothing but 0.97 square. That's the variance. Okay. Okay, now let's see how to, we have seen mean, we have seen variance, we have seen standard deviation, we have seen all these three, how to estimate them from the grouped frequency table when the data is not given, when the data values are not given. Okay, so let's see the quartiles, how to estimate the quartiles. Okay, so we can estimate quartiles using boundary values. This is where we are going to use class boundaries. Okay, not from the midpoint values, now from the class boundary, with a method known as interpolation. As the term indicates, you're going to interpolate the value, the quartile, you're going to estimate by interpolation. That is, find a value between the given range. Yeah. So what? I will show you how to do that. Yeah. So let's estimate the median Q2 first. Let's first find the median, the quartile 2. Okay, that's easier, isn't it? Okay, we all know that, we have seen that if we have 30 data value, Q2 should lie at the 15th position. We know that, isn't it? Yeah, 30 divided by 2 is 15. So our median should lie at the 15th position. That means 2 plus 2, 4, 4 plus 4, 8, 8 plus 8, 16. So somewhere here, because 16th value is here. So somewhere here, our median should lie. Yes. So that's where. So that means there are 15 values before this position. Okay. Okay. So this is the class where our median lies. Assuming that the values in a class are distributed evenly throughout the class, this class starts at 4.95. Can you see? This class starts at 4.95 and ends at 5.45. Okay. Starts at 4.95 and ends at 5.45. And contains 8 values. And we want the value in the 15th position. Okay. So we have somewhere here 8 plus 8, 16. But somewhere here, in between somewhere here, the quartile 2 lies. We don't know that. Given 8 values occur before the class, but we know that there are 8 values before this class. So there are 15 data values still here. There are 8 values still here. Yeah. And that means in between this, there are, yeah. So you can find the different number of data values in between that. Yeah. Okay. So how are you going to find the quartile 2? The easy way is to find it this way. Yeah. Quartile 2 lies between 4.95 and 5.45. Yeah, because it lies in this class. So it should be 4.95 plus the fraction of data inside that. That is 15 minus 8. 15 minus 8 divided by the number of data in that 8 times the difference between the class boundaries. Okay, that's the way you find the quartile 2. Okay, you estimate the quartile 2. I shouldn't use the word find. Estimate the quartile 2, the median. Okay, okay. If this is confusing for you, let me show you how to figure this out. Okay. Yeah, actual value of quartile 2 using the given data was 5.4, which is almost close to that again. Once again, you can see how the estimation is so close to the actual value. Okay, let me show you a different way to understand the same thing. It's the same thing. I'm just going to approach this interpolation method in a different way. Yeah, like I'm just showing you how we can derive that. Yeah. Okay, we know it lies in the 15th position. Yes. So that means we have data till here is 15, yeah? And we know that till here it is 8. Okay, let me draw that in this way. Let me take this class 4.95 to 5.45 in this way. That is easy to see, okay? It is much easier for you to see. So 4.95, and that's your class interval 5.45, okay? So now we have data from here to 5.45. How many data values are there? 16, isn't it? Yeah, there are 16 values. And from, let's imagine the Q2 lies here. That is 15. Okay. And then 4.95, let me take another color. till here it is 8. Okay, now let me compare the width of each. Okay, so I want to compare, this is Q2. So I have Q2 minus 4.95. And how many data are there in between this? In this 4.95 to Q2, 15 minus 8, isn't it? Because till here, from here to here is 15. So 15 minus 8. So that is the number of data in this region. Yeah, this region. 15 minus 8 data. And the width is Q2 minus 4.95. Okay, similarly, between this width, 4.95 to 5.45, I have 5.45 minus, I'm just comparing the width. Divided by how many data are there between this to this? Yeah, 5.45 to this, 8, isn't it? See, there are 8 data in this class. So I put 8. Now I can rearrange this. Let me put it in a clear thing. See, for Q2 from here, Q2 minus 4.95 divided by how many data are there in this region? 8, isn't it? 15 minus 8, isn't it? Because till from here to here is 15. 15 minus 8 is this region. This region is equal to 5.45 minus 4.95 divided by 16 minus 8. That is this many data, yeah? Okay, and then you rearrange it, Q2 minus 4.95, take 15 minus 8 over there, and then Q2 is equal to 4.95 plus 15 minus 8 by 8 times 5.45 minus 4.95. Okay, so this is how you calculate the quartile 2. Similarly, you can calculate the quartile 1 and quartile 3. Okay, let me show you how to calculate quartile 1 and then you can calculate the quartile 3. Okay. Okay, let's use the same interpolation method to calculate the quartile 1 and quartile 3. Quartile 1. Let me ask you, where will quartile 1 and quartile 3 lie? Which position? Good. Yes, quartile 1 will lie at 1 by 4th, that is 30. 1 by 4th of 30 is equal to 7 by 5. 7.5, 7.5, fifth position, and quartile 2 will be at 3 by 4th of 30. Yeah, now we are talking about the position, okay? 3 by 4th of 30. Again, you may say, why is it like that? Why are we not using the same method as we did before? Remember guys, this is estimating. We are only estimating and we do not have the data value here. So that is why we are choosing this technique, yeah? So 1 by 4 times 30 is 7.5 and 3 by 4 times 30 is 22.5. So Q1 lies at 7.5th position and Q3 lies at 22.5th position. 22.5th position, yes, that's right. Okay. Now using interpolation, let's estimate Q1 and Q3. I will do the Q1 for you and then you can find the Q3 for us. Okay, let's do Q1 first. Okay, so Q1, it is at 7.5th position. That means we have how many data till here? That means there are 7.5 data values till here. Okay, and how many data values are there till here? 4. Yes, and how many data values are here? 4. Yeah, okay, so let me say, so that means and which class is it? 4.45 and 4.95. So let me say Q1 minus 4.45 by 7.5 minus 4 is equal to 4.95 minus 4.45 divided by, so between this there are 4, isn't it? There are 4 of them. 4 data by 4. That is the width, isn't it? This many data values lie in that class width. Okay. So now we have to rearrange, and then you get, if you rearrange, you get 4.45 plus 7.5 minus 4 times 4.95 minus 4.45 divided by 4. And then you can calculate the value of Q1. Now over to you guys. What is the value of Q3? Very good. Did you do this way? Yes, that's right. For Q3, it is 5.95 plus, how many values are there? 22.5, isn't it? So 22.5 minus 22 divided by 3 times, because it lies in this class, you have 6.45 minus 5.95. And you can find Q3. Excellent. Very good. And now if you compare with the actual data values, you can see how close it is. See, Q1 is 4.9, and what we estimated was 4.89. Q3 is 6.1 actual value from the data, but here estimation is 6.03. Okay, so that's how you estimate the quartiles from the class boundaries using interpolation. Okay. Now, one more thing. The quartile estimates we have just derived from the grouped frequency table for the 30 cholesterol data values are like this, okay? And you can do the same using the histogram. You can use interpolation and find the quartiles using histogram. And how are we going to do that? I'm going to just show you how we do that. We can do the same way. We can divide this histogram into 4 equal parts. Yeah. So what you do is, for example, you calculate the area of this, area of this. So you know that there are totally, add the areas and you can find the, so from each area you can find the frequency. For example, from the first class, you can find the area. You can say, you can multiply the class width with the frequency density and you will get the area. So this class width times frequency density is, what is the area? 2. Yeah. Similarly, class width times frequency density is 2. Similarly here, 4, 8, 6, 3, 5. Now total is, you sum them all up and total is 30. Now 30 divided by 4 is 7.5. That means each quartile divides the whole histogram into 7.5 parts, 7.5 values. Yeah. So that means each part will have 7.5 data values. So where will it lie? 4 plus 4, 8. So it's almost here, isn't it? So again, this is an estimation, okay? So what you do is you just take the 8, yeah, and then you interpolate and find the quartile 1. So you can say that quartile 1 is here, quartile 2 is there, quartile 3 is there, yeah? So by interpolation, you can clearly find the quartiles. Okay, now my question is, these also divide the area of the histograms into 4 equal parts. Why? Why is it dividing? The answer I've already given. Answer is each 1/4 of the histogram contains a frequency of 7.5 values, data values, and is 1/4 of the total histogram area. So what we see here is you can transform the table into histogram and histogram to the table group frequency table, and you can estimate the quartiles. So it is just the same. Yeah. Okay. To summarize, if we do not know the individual values in the original continuous data, we can estimate summary statistics. For example, you can estimate the mean using the midpoint values. You can estimate the standard deviation using midpoint values, and you can estimate all the 3 quartiles by interpolation of the class containing the position of the quartile. Okay, so that's all for now. We'll do more problems on quartile, estimation of quartiles and mean and standard deviation in the seminar. Okay, so we have seen how to estimate the mean, variance, standard deviation, and all the quartiles, lower quartile, median, and upper quartile. Okay, that's all for now, and see you in the part 2.